Thank you all for joining me today. My name is Don Turner. I work on the partner engineering team at Google. I basically get to play around with synthesizers, MIDI keyboards, sequencing apps, all sorts of cool toys. Yeah, I basically have the coolest job in the world. This is my desk. My colleagues hate me because I get all the best stuff and I'm constantly bombarding them with sine waves. Also with me today, all the way from sunny California, we have some experts in Android audio. We have Phil Burke and Glenn Caston, who are both software engineers on the Android audio engineering team. We also have Ian Lee Lewis, who is sat over there, who writes code, mostly code for high-performance audio. And we also have Mark Barkinger, my colleague, who works on the developer advocacy media team. So, as well as answering your questions today, we also really want to hear from you about your thoughts on Android, good or bad, like especially bad. Like we read the forums, we see the press releases, you know, we see all the negativity about Android, and we do listen, and it does help us shape the roadmap for Android. So if you have particular frustrations or particular barriers to publishing on Android, we definitely want to hear from you because we can change our engineering direction based on your feedback. So, first question, what is the most important aspect of audio performance? Anyone?
I heard, what did I hear?
Sorry, who?
Latency.
Give this man a prize. Latencycy a Okay, we're going to talk a lot about latency today. And I've got a personal story about latency. So I am a DJ. I used to DJ in some of the most terrible clubs up in Nottingham playing drum and bass. This is me when I was 17. Terrible hair. I tried to dye it blonde, but it went ginger. This is the only photo evidence that there is of this. So anyway, I was like a big vinyl fan. Always stuck to vinyl for a long time, but then Serato brought out a device called an SL1 with time-coded vinyl. And I bought one of these because I was like, I'm so sick of lugging records around. I just want to carry a USB memory stick. And I bought it, and I was a bit skeptical as to how good it was going to be in terms of latency. But the first time I put this time-coded vinyl on a deck and started scratching, I was astonished at how good it was. I think it was like 7 millisecond latency. And that gave me an idea of how good latency should be on professional audio devices. And it also gave me kind of a goal and a passion, now that I work at Google, to get Android as good as that. And that's really the goal within our team, to get Android to be as good as professional, dedicated audio devices. So today we're going to talk about the stuff that we introduced in the latest version of Android, Marshmallow. We're also going to talk about the recently launched Pro Audio devices, as well as latency, MIDI and hardware support. And then, so this is only like a brief start to the workshop. So we'll probably talk for like 10, 15 minutes. And then we're going to do like a code lab, which Fabian's prepared, which we're going to build a synthesizer and sampler using JUCE 4. And if any of you have picked up the devices, you're going to be able to deploy that onto the new Android Pro Audio devices and have a play around with them. So, should be fun. So first, let's get the bad news out of the way. Some Android devices have terrible audio performance and always will do. No amount of software updates or driver fixes is going to change that. That's unfortunately just the way things are. Also, we're aware that the Android platform has taken a long time to improve its audio performance, and we know that this has caused some frustration, particularly from you guys in the pro audio industry. We do listen, and we're sorry. We do have good reasons, though. Firstly, Android runs on over 1.4 billion of the world's smartphones. It is by far and away the most popular smartphone operating system. And one of the reasons for its success is the fact that it runs on this like diverse range of hardware. There's literally tens of thousands of different hardware configurations that Android runs on. For consumers, this is fantastic. They get choice. You know, if they want to spend $700 on a smartphone, they can. They can buy like a Samsung Galaxy S6 Edge. Or if they want to spend a few $100s, they can buy like an Android One device. And as we move on, we're seeing lower and lower end and higher end Android devices. So this is great. You know, as a consumer, you get this massive range of choice. But for audio engineers like Glenn and Phil here, this is not quite so good, since they need to design an audio architecture which works reliably on all of these devices and with all the other parts of the Android system. So this is pretty complicated. So this is the Linux kernel here, which Android relies on. And the point here is that Android has to do a whole load of things. It must make sure that the device can always receive phone calls, that the UI remains responsive, that apps respond to touch events, and that the device doesn't get so hot that it like melts the user's hand off. And you might be thinking here, well, okay, that's, you know, I can understand that problem, but other hardware manufacturers, other operating system makers like Apple, do this perfectly well. So like, why is it such a problem for Android? And really, the issue is that Android relies on OEMs like Samsung, LG, Huawei to build hardware and drivers which Android then runs on. So whilst we have some hand in the driver performance of these OEM drivers, we can't force them to do great audio performance. They have to decide themselves, okay, yeah, we want to make sure that this whole driver stack works together to create an awesome audio experience. So this has led to some devices having great audio performance, like the Samsung Galaxy S5, at the cost of extra code. So to get great audio performance on this device, you have to use the Samsung Professional Audio SDK, which requires extra engineering resource. And it's also led to devices like the Nexus S, which are just terrible. So unfortunately, this has led to a situation where Android is seen as being universally poor in terms of audio, and this leads major music app developers to avoid Android, and this is really a problem, because then the OEMs don't see that there's any demand for high-performing audio apps on Android, so they don't invest in the engineering resources and the hardware in order to deliver really low latency audio devices. And no amount of engineering work from Google can solve this. So it needs these OEMs to come on board and really value the fact that consumers want high performance audio applications. So I can tell people are like, well, this is all sounding a bit depressing. Like, so here's a picture of my cat in a box. Suddenly everyone's happy, great.
I think it's time for a prize.
Okay. Yeah, this is the prize. That's genuinely my cat, by the way.
This is a yes/no question. Is there hope? Yes. Congratulations.
Easiest question in the world. Let's face it, you weren't going to win a prize for saying no there. So the good news, things are getting better, and in fact have been getting better over the past few years. In 2012, we released Jelly Bean, which included features such as the fast mixer thread, which allows you to bypass any signal processing which happens on the output signal path. And in Lollipop, we also introduced low latency input. So this is why you can get very good round trip latency to Android devices today. So actually, this has meant that there's a growing number of good performing Android devices in terms of audio. And here we have a graph representing number of unique devices versus latency. So one of the questions that we hear a lot is, well, what's my addressable market? Like, how many devices, if I build an app, am I going to be able to deploy onto, which then have good performance, like I'm not going to get negative reviews? And the answer to this is here, because if you pick the latency that you require for your app, then you can basically cut off the devices that you don't want to deploy to. And Google Play makes it really, really easy to do this. So yeah, we're seeing more and more of these, and it's kind of up to you to decide how many devices makes it a commercially viable decision. Specifically with Nexus devices, we publish the round-trip audio latency stats, and you'll see here down the side we have like progression over time and release of Nexus devices and round-trip audio latency, and you'll see here the latest devices all have sub 20 millisecond latency, which is pretty cool. The other point here is the trend. Like, the trend is very, very much downwards. And this doesn't happen by accident. This is through years of engineering work and working with OEMs. So what's new in Marshmallow? And the answer is, on an engineering side, nothing. Like, we've done all the work already that is required to get low latency audio on Android. The thing that we did introduce in Marshmallow was a couple of device-specific tweaks, particularly for this device here, which is a Nexus 9, which reduced the frame buffer size to allow sub 20 millisecond latency. But for the most part, there's nothing new in Marshmallow. Lollipop was the major release for getting good performance on Android, and that's now been out for a year and has a market share of like 25%. So what did we introduce? We introduced a new standard called professional audio. And professional audio devices must have a less than or equal to 20 millisecond round-trip audio latency. Also in the specs, it says that professional audio Android devices should have a round-trip audio latency of less than 10 milliseconds. So this is kind of stating our goal. Like, we know that 20 milliseconds isn't considered amongst audio professionals as, you know, the benchmark on which to aim for. 10 milliseconds is much closer to that. So this kind of gives you an idea of Android's direction. The other cool thing is, with this professional audio feature, it allows you as developers to detect whether or not you're running on a professional audio device with one line of code. So you can like alter your buffer sizes or change the features in your app just by checking. And in fact, this is exactly what JUCE does. JUCE will, on a pro audio device, will reduce the buffer size down to the lowest possible. So I was talking to Fabian the other day, a lot actually, and he was telling me that when he speaks to developers about Android and tells them, hey, there's these new devices which have got great latency, they say, we don't believe you. And that's the end of the conversation. So I figured I would do a live latency latency And so I have an app here which is going to output a sine wave and I'm not going to play it through the speakers, so you're not going to get deafened. And then it'll record at the same time. So it just detects the round trip latency. So yeah, I will. So it sounds like this. And now, because there's a lot of background noise, it's not detecting at the moment. So what I'm going to use is a loopback connector. And this connects the output to the input and bypasses any signal processing which is introduced by the inbuilt microphone or speaker. So plug this in and start the test. There we go. So this will run, I think it runs like 10 tests and takes the average of them all. Yeah, nothing. It's running the test. It's running the test. So overall, 14 milliseconds. There we go. Oh, hang on. So hopefully that's proof Go on, Glenn. Are you going to give that to me?
No. So, why is latency over the speaker higher than over the headset jack?
A reduction on the
Okay, you want to try?
because of time propagation in the air. It's like 3 milliseconds per minute.
That's not enough. I want to hear more. Yeah?
That's the high said it has equalized and stuff to compensate for the phone shape and deficiencies in the speaker and stuff.
Absolutely.
Yeah.
You'll get second prize. Okay. There you go. Thanks. Let me get you a. Here you go. It's a consolation prize. it's a perfect answer, but his was a little bit more spot on. Thank you.
So I'm sure if you ask Glenn nicely, he might have a loopback connector if you want one, but the schematic is online if you want to do latency testing. So which devices are professional audio devices? The Nexus 9, which is available from Argos for only $199. I'm not on commission, but it's cheap. You know, it's a cheap price for a very high performance tablet. Also, the newly released Nexus 5X and 6P devices are all sub 20 millisecond professional audio devices. So, professional audio from an Android standpoint isn't just about latency. It's also about supporting various audio accessories and standards, and MIDI, USB audio, that kind of stuff. And one of my esteemed colleagues, Phil Burke, is going to talk about MIDI briefly. So, welcome, Phil. Please take it away. Okay. Cool. I'll get out of the way.
All right, well, MIDI is a subject that's been near and dear to my heart for a long time, and it seems like Android should have good support for that. So in M, we have added native support within the operating system for MIDI to reach an app in 3 ways. So the most common application is plugging in a USB keyboard into a phone or tablet and then having those MIDI messages delivered to the app. There's also a new way, which is the new BLE MIDI standard, which is a standard that's actually came originally from Apple and was adopted by the MIDI Manufacturers Association. So, and it's just in the process of being ratified. And the Japanese manufacturers are keen on it, and a lot of new devices coming out. In fact, the Rolly Seaboard Rise supports BLE MIDI. So you can have wireless. And one real advantage of that on the mobile platforms is that you can be powering the tablet while you're also doing the MIDI, because you're not tying up the USB port where you'd normally be charging. Something that's very different in the MIDI on Android now is that your app can be a virtual MIDI device. So you can provide a MIDI service. So if you write a synthesizer app, it can just be a simple app with like no GUI. And when you install it, it becomes available and it looks to the other apps like a keyboard or a synth that's actually plugged into the system. So that means you could write a synthesizer app, and then other apps can use your synthesizer. So if someone else writes a composing app, they can use your synth app. You can also turn things around and connect the Android device to a laptop and as a peripheral. So it's going in a different direction, and then you can use the multi-touch on the Android device as a nice controller, MIDI controller. The MIDI API is very simple. The model, some people, it looks a little like it's backwards compared to some APIs, but it's not if you think about it from the standpoint of the devices. So if you create a synth device, your synth device will have an input port. And if you can connect different devices, but you can also talk directly to an input port. So if you want to send messages to the synth, you can open its input port, and then you send messages to an input port, which seems a little funny, but it's but that's what synths have as input ports. So you can query the devices, you can register as a listener to get if someone hot plugs devices, and then you can open a device asynchronously, and then once you have it, you use this MIDI receiver interface, and you can either send to a MIDI receiver, or you can register a MIDI receiver to receive messages, and it'll call your on-send message. So the data comes in just as a byte array with a timestamp. And it's a nanosecond timestamp that's the same timestamps as the audio subsystem. So you can synchronize your audio and your MIDI. So that's it. Well, let Don hit the button on this one. So.
Cool. Thank you, Phil.
Sure.
Next up, we have Ian Lewis, who's going to talk about high-resolution audio.
Do the prize.
Sorry. Sorry. Yes.
Okay. All right. So yeah, we've also decided to augment the pro audio standard with what we're calling high resolution audio, which you're probably thinking, well, that's a buzzword, and it is. So here's what it means to us. First, 24-bit processing. So we went ahead and made the entire signal chain 32-bit floats internally. And then we also work well with 24-bit ins and outs. We're adding support for 96 kilohertz and over. That's something it's hard to get too excited about as a consumer, but as a content creator, might really be nice. So you record at 96 kilohertz, you push more of the noise into the inaudible bands, and adds about a bit of noise reduction. And then finally, and this is what I'm really excited about for content creation, is at least 4 channels. And in fact, most of the, or many of the multi-channel devices you'll encounter in the consumer space are 6 to 8 channels. Unfortunately, right now, the only way we can address those in C is by treating them as surround channels, which is a little suboptimal, but there should be a patch for that fairly soon. All right.
Okay. Yeah. So JUCE supports the new features in Android Marshmallow and the low latency path, audio path that's already been there in Jelly Bean. It supports USB MIDI. It supports Bluetooth MIDI. There's a cross-platform way to pair MIDI devices in JUCE. So you use the same interface for iOS, for OS X, and for Android. And as Don already said, JUCE can detect if you're running on a pro audio device, and we'll lose as a default buffer size, we'll use the lowest latency. But we'll talk a bit more about that in the workshop. So, quick, back to you.
Cool, thank you. Started with the code lab. We know that the documentation for doing stuff with audio on Android is like atrocious or non-existent, and I'm very pleased to say that at about 10 p.m. last night we pushed a new site which covers all of the major things to do with developing high-performance audio apps, or covers USB audio as well. And this is now live. So this is going to be like a central place where we can publish code samples, development guides, documentation, and the really nice thing is it's controlled by the Pro Audio team within Google, rather than having to go through months of like reviews and stuff. So yeah, we're excited about this. Go on, Glenn.
What's the most important thing you should walk away from this with? In your mind.
A working example.
No. C65HKU. Okay. Anyway.
Get rid of the guy who said
I should have given it to myself.
So yeah, new website. So I just wanted to round off by saying that to me this feels like a turning point for Android. We've been through the dark days of terrible audio performance, and we're now finally starting to see devices which have very good audio performance. In the last week, we had the first ever piece of positive press from Android Police about audio devices. Oh, sorry. Is that better?
Yeah.
Okay, so yeah, we crossed the 20 millisecond barrier. We had the first piece of positive press. I mean, anecdotally, we've been meeting with partners all week, and historically what they say to us is, yeah, you know, Android's okay, but we make a lot more money on iOS. And for the first time this week, we had multiple partners say to us that it was roughly the same, iOS and Android, which is music to our ears because ultimately it's about making money off development. And so the revenue side is definitely improving on Android as well. We also saw the first ever proper audio workstation published on Android, app called Stagelight by Open Labs, was published this week on Android tablets and phones. So in summary, we need you to get behind Android because we are reliant on OEMs like Samsung and LG to build these devices, and we need the apps on the store to convince them that they need to take this seriously. So with that, thank you very much.
One question about the new support for 96 kilohertz. I think in the past the lowest latency was only possible at 48 kilohertz. Does it mean now we can get the lowest latency also at 96?
So I think I can take this, but cut in if I'm incorrect. The lowest latency is only achievable at the device's native sample rate, because otherwise you would be asking the device to downsample for you. So if you do the resampling yourself and then output at 48K on the device, then you can still get a low latency path. But if you ask the device to do the resampling for you, then you will not be put on a low latency path.
Okay, sorry, but this is true only for built-in audio. I mean, if you are getting your audio from a USB device that support multiple sample rates, so what's the native sample rate in that case?
The question is, how does that work with USB audio?
Yeah. Who has the mic? It's a great question. So what Don said was exactly right. Over the built-in speaker and mic or the headset jack. Over USB audio, if you know what the native rate of the USB peripheral is and what our USB host is using, then the optimal sample rate is whatever that is, and then there's no resampling and the latency is the lowest possible at that rate. If you don't know what it is, then we might not go over the fast path. So one of the issues we know of in our API is that we need to provide better information exposing what the native sample rate is of each peripheral. So that's on our to-do list.
Cool. Give that guy a prize. Okay.
Is it possible to check if a device has professional audio directly from the store and not inside the app?
Yes.
Okay.
So what you do is in your app manifest, you specify that you require pro audio, and then your app will only be available in search and will only be able to be deployed onto Android professional audio devices.
Perfect. Thank you.
In fact, sorry, just to add to that, when you upload your app into Google Play, it will tell you how many devices and the specific models of device which are supported. So if today you upload an app which only supports professional audio devices, you will only see Nexus 9, Nexus 6P, and Nexus 5X. So then you have to do a bit of your own research to say, okay, well, how many devices do I know of those that are in market, if you want your addressable market size?
Hi, this might be too general a question, but the the cheap Android mini PCs, do you have any experience or thoughts on the audio performance of those?
Mini PCs?
Well, the kind of, you see them on Amazon. No, the more kind of, the £50, $50 kind of little mini PCs that you can use as HT PCs and
So I don't have any experience with them at all, sorry. Anyone? Mini PCs running Android? I mean, we have the Nexus player device, which is like for TV.
these are more OEM devices.
Well,
so.
Are they running?
That general question, I think I have a general answer, which is just that.
So it's really unusual to find a set of hardware that's incapable of achieving low latency in Android, just as far as ARM SoCs go. Unfortunately, as Don mentioned, we've sort of hit a limit of where we can go with just our software and the hardware. If you were around in the 90s, you probably remember having to, disable your network drivers in order to run your DAW on Windows. It's the same situation here, where a driver that considers itself very important to, let's say, telephony, could disable interrupts for tens of milliseconds, which prevents audio from being able to process. And what we're seeing is that the higher end devices that are being sold at higher margins are able to spend the engineering effort to actually reduce the driver problems, whereas the lower end devices aren't targeting this market, and it's probably not worth it to spend that effort. So we are seeing sort of a price curve. It's not a strict rule, but it's a general rule of thumb.
I would like to ask about the MIDI over BLE implementation. What kind of latency can you
7.5
get?
milliseconds.
So
7.5 milliseconds
is it
best.
possible?
Yes,
That's
I saw a demo of it
minimum,
on Tuesday. I can guarantee that it's possible.
That's great.
Yeah. It's fantastic. Like the demo that I saw was for a Bluetooth LE connected crossfader, and so you can scratch on the tablet. You control the audio. Rather, you move the audio sample back and forth on the tablet using the touchscreen, and then you can cut with the crossfader, and it's very, very impressive.
Just to clarify, they weren't using the MIDI mic. It was a proprietary mic.
Oh, sorry. Okay, sorry. That's the Bluetooth latency. For MIDI, Phil, you have a different answer.
Yeah, this demo, they were doing a proprietary protocol. But so BLE has a minimum connection interval of 7.5 milliseconds. And then there's a millisecond maybe that might be added just to get the data out through. But the connection interval is the main component of that.
Okay, cool. So
also, we've probably mentioned that is partially configurable during negotiation between the device and the host. So you may not find that every device has that sort of low latency.
Yeah, the host can set their lower limit.
Yeah.
Hi, if you have an app that would work with non-pro audio, but obviously benefit a lot more with pro audio, how much difference in the JUCE API calls would you have to make, or would it all be automatically done for you?
It's no difference. So the only thing we do different on a pro audio device is that when JUCE chooses a default sample rate, it will on pro audio devices choose the smallest. If it chooses the buffer size, on a pro audio device, JUCE in the background will just choose the smallest buffer size available as the default audio buffer size. That's the only difference from a JUCE perspective. So this means, as Don mentioned, there's some older devices that have great low latency audio. They're just not marked as pro. The only difference there would be is that your user would have to select a lower audio buffer size, because JUCE on older devices, on non-pro audio devices, will use a more conservative audio buffer size. That's really the only difference.
So is there any way, so you'd have to make that a user option to get better performance and let the user experiment?
Yes, I mean, but this is also currently like with professional audio apps on desktop, right? I mean, there we don't use the lowest possible buffer size either. If you know, like from the JUCE demo, you can select the smaller buffer size if you want to. So I mean, this is already standard with other JUCE apps. Also on iOS, I don't think we use the smallest buffer size. So it's only concerning the default buffer size that JUCE will select.
Can you just give a quick overview of what the OEMs actually have to do to create a pro audio device? Is it just sort of Linux kernel level driver work, or is there something else higher up the stack that they have to do to sort of enable pro audio on an Android device?
So as far as I understand it, it is mostly driver work. They also must provide what's called a hardware feature flag, so they need to indicate that they are supporting this feature. And if they want all of the, we call it GMS core, Google Mobile Services, which is what all the proprietary stuff that Google gives them, like Google Maps and all the good stuff. If they want all that, they have to go through a process called compatibility testing, where we actually test their device to make sure that it does conform to the professional audio specs. So they can't just like chuck out a device in market and say, hey, this is a professional audio device, but it has a round trip latency of 100 milliseconds. They could do that, but they wouldn't get any of Google's stuff. So in order to get Google's stuff, they have to go through the compatibility test suite, and that verifies that they are doing what they say they are doing.
Okay, so say I had, now I'm thinking from a hacker point of view, I have a board and it's running Android and it isn't pro audio level myself. I know I can get a better driver, or I can tweak the driver to fix some of the issues because the board vendor just didn't give me a good support package.
Yeah.
Is it relatively simple for me to sort of do some tweaks and then have that platform running, or do I have to go through all this kind of shenanigans with you guys before I'm sort of...
Well, just to clarify this, I'll let you answer in just a sec. The shenanigans are fully automated. So you can go through this process as an OEM very, very quickly and simply. Glenn has more to add on this, so I'll let him.
Ian was mentioning this, but I just want to emphasize what Ian was saying, which is that part of the problem is the audio driver and configuring the audio driver properly and making sure there's not any additional delays in the signal path, such as a DSP or something like that, getting the buffer sizes down, things like that. But at least in my experience, most of the problems that I've found are not related to audio. It's totally unrelated things like Wi-Fi and stuff like that that cause a problem. So when you're building your custom board, don't just think about the audio. You have to think about the whole system, and because any part of the system can cause audio to fail. So that's what makes it hard.
There.
Yeah, just to be more specific. So Glenn brought up a really good point. So first, your BSP is going to need to support low latency across the board, but also there are these value-added codecs. So Qualcomm, I think, is the most common one, where they do a significant amount of processing off the main board, and Glenn worked tirelessly to get a Qualcomm driver that allows you to disable that, but you would need to get that in your BSP as well.
Any more questions?
So you do test the round trip latency. Do you also test dropouts, or because you can have a very low latency with bad quality actually?
So that's a great question. Glenn's laughing, but he knows the answer. Yeah, you can answer, yeah. So this is a big deal. This is something we talk about a lot.
Yeah. So great question. Yeah, it's really easy to get low latency if you're willing to tolerate glitches. So we actually had an intern who was working here this past summer who added a feature to our latency tester that would measure dropouts in two ways. One is by actually looking for glitches. She wrote an analysis phase that would look for glitches on the audio that was returning. And then the other thing that she added was measuring the period of callbacks. It turns out that there's a very high correlation between irregular callbacks and glitches. Basically, if you have a late callback, then you're almost certainly going to get a glitch. Anyway, so that test is done, and we're using it now. However, we don't yet have it in our daily build testing, and that's on my to-do list, is to get it into our daily build process so that we can run that test for long periods and measure the dropout rates. And then we'll be giving that tool out to our OEM partners too.
So that means the CTS test that we talked about would also incorporate this jitter testing as well. So making sure that it is a reliable 20 millisecond round trip. Fabian, let's get started then.
Yes, let's get started. So
Get out of the way.
we'll be doing a workshop now on how to take advantage of all these features in JUCE. And also this will feature the new Android exporter in JUCE. And along the way, I'll talk about how JUCE deals with these pro audio devices, how it deals with USB MIDI, etc. Okay, so if you looked at the website, the abstract for this talk, there's some things that were suggested you do beforehand because I don't know how the wireless will be here. One thing is to get the latest version of JUCE. It's best to clone it from GitHub or download the latest version from the website. Also, you can use the version that's on your USB key that was given to you at the start of the workshop. That should work fine as well. But anything that's older than a week, there's some bugs in there that that it will work, but there's some there's some hiccups sometimes, some random hiccups that might happen with the Android Studio exporter. So yeah. Then also in the abstract, it says that you should clone this tutorial, the repo of this tutorial in the JUCE examples folder. So this is required so that we don't get any hiccups with the module paths, because sometimes you have multiple JUCE folders, and if you put it in the examples, I know exactly where the modules are. It's ... modules. So I'm just going to show where I cloned it. It's in JUCE examples, and then you should see this. Where is it? JUCE Android Synth. If you still need to clone it, it's only a few kilobytes. So here, let me just show you the command. So it's HTTPS. I'll just bring this up. It's HTTPS Hogliux. There, Hogliux JUCE Android Synth. So if anybody wants to follow this along live, then please clone this in the JUCE examples folder. That will just make life a lot easier. Everybody has that address. I'll pull this down so you can see. So along this tutorial, if you ever get stuck, there are a lot of branches on this repo. So you can, oh, that's wrong, that's the JUCE. Let me go to examples. Sorry, JUCE examples. I have a monitor here. And then you will see that they're all labeled 1, 2, 3, 4, 5, 6, 7, 8, 9. And throughout this tutorial, I'll always tell you exactly where we are. And then you can just check out that branch. If you ever get stuck and you just want to skip ahead, then feel free to do that. But please just tell me to stop if you have an issue and say, oh, I didn't get this far, something's wrong, something's not working. So also give us good feedback about what might not be working and what things. Because yeah.
The speaker next door said he was going to have his break at 10.
Oh, right, exactly. So we're going to synchronize the break. Actually, this might be a good point to do the break then, because it's exactly 10. So yeah, so if people want to get this set up, and also if everybody has cloned, if somebody doesn't have Android Studio, this is probably a bit late, but try downloading it. It's big. Yes, so let's have a break and let's come here back in 5 minutes.
think that would be good.
And we have one more prize available, which will be at the very end for the best demo.
Okay, so yeah, as I said before, yeah, you should have cloned this repository. I think we're going to include it into JUCE examples anyway, but it's not in there yet. So if somebody hasn't done this, here's the address again, just for the web feed after the break. This is what you'll need. And the branches will sort of, if you ever miss a step, you can just always check out one of those branches. And I'll always say where we are. Okay, so this is, when you clone this, it's a bare bones project. I haven't hooked up the synth. I haven't added any Android Studio exporter. So don't be worried if like, hey, this doesn't work on my machine. That's deliberate because we're going to show you how to actually get Android running if you start this on your own. So let's just look at this project for a moment. Here, JUCE Android synth, right? When you clone it, it will have 3 desktop projects, so Windows, Linux, Mac, and whatever you're on. You can just, I'm on my Mac, so I'm just going to open the Xcode project. And I'm just going to run this. That was worryingly fast. Okay, so this is how it looks like on OS X. You'll see it's not hooked up, so we'll do like stuff like what I can't even do anything. Can't hear anything. That's the way it should be. So that should run on Linux and on Visual Studio on your desktop. And now we're going to go add an Android Studio project. So now we want to basically port this synthesizer to Android. So we're going to open the juicer file in the Pro Juicer or Introducer. So I don't need the live coding features for this tutorial. So you could be doing this in the Introducer or in the Pro Juicer and not have a live coding license. So I'm just going to open this. And the very, very first thing I'm going to do is I'm going to, before I do anything else, I'm going to check the global preferences. So we want to be sure that all the SDK paths are correct here, the Android SDK and the Android NDK. And if you've installed Android Studio before installing JUCE, then JUCE will automatically pick up the correct paths here. The problem is if you've ever had the Android command line tools installed in your computer and used the Introducer or Pro Juicer with that, then it might have picked up another path, and then it stores that, and stores that forever until you delete the preferences or you change it here. So if you've now just cloned JUCE for the first time, then these paths will be correct. But if anybody has changed these, then you should probably on Mac change them to these files, folder locations. Okay, so let's add a new exporter. So I'm just going to click here on Android Synth, right click, and then there's create new export target, Android Studio. It's down here. I can see my new export target is right here. And now one thing I just want to make sure is there can also be a default module path when you add new exporters. So if I click on here, and the path for the module should be the same as all the others, // modules. Again, this will depend on your global preferences. You might have chosen another module folder as a default. Please change this to // modules. And if you've changed it here in Audio Basics, then you click on modules, you click on this, on the one that you've changed it for. If you change it for a JUCE Audio Basics, then you just do set paths for all modules. And this will then just make sure that all the modules use that path. Okay, so if we've done that, we're going to save this project. And let's bring up Android Studio. And I'm going to do open an existing Android Studio project and navigate to that location. So development, JUCE, examples, JUCE Android Synth, builds, Android Studio, there it is. And the first time you do this, so if you've exported a new Android Studio project and you then open this in Android Studio for the first time, you will see that Android Studio will start there. We'll start building it will start analyzing the project layout. It will start going through the symbols. It will start pre-compiling things. If you've just downloaded Android Studio, it will also make sure that you have the right SDK versions and actually download them now. So if you've read the abstract of this talk, it told you to just open a fake sample project to get the right dependencies so that you should already have them. But if you've just downloaded Android Studio now in the break, then it will probably be downloading some stuff now. You can see here there are some processes running, which is now doing like analyzing symbols. And if you click here on the project tab, and then there's app, JNI, so for Java native interface. And then here you have all the JUCE modules for convenient browsing. If you need any reference, you can just go here, just like in Xcode, or in Visual Studio, you can browse the JUCE source code. You can browse your own source code, which is still loading because here you can see it's still working. Just give it a moment. There we go. And while now Gradle here is building the project in the background, that can take a while. As you know, if you just create a new project with JUCE, it will have to compile all the modules, which takes some time. This is exactly what Visual Studio is now doing in the background. It does that when it's idle, just to get all the symbol names and to have auto-completion. So just to look at this structure for a moment, we have a main file, just a JUCE application main. It initializes a device manager, and it has an audio processor player down here, but we're not connecting anything to that player yet. So this is the project. Then we have a main component, which is that little thing you just saw before, the keyboard and the slider. So it just has a keyboard, has a record button, and it has a slider which will then control the reverb of our synth. Okay, to run this, we click up here and select App Native. This basically chooses what part you want to debug. Do you want to debug the Java code, or do you want to debug the native code? If you are building JUCE, you probably don't want to do much in Java, so you should always have that on App Native if you're doing anything with JUCE. And we'll just click the play button here, and this device will probably ask me now, if you've just gotten a device off that table, it will now ask you if you want to allow USB debugging. So I'm just going to do OK. If you don't have, I'm not sure if all of these have developer mode installed. If not, then just shout. You have to go into build number and click that 5 times to become a developer.
They should all
7 times.
7 times, okay. So it's,
you are now a developer.
Yes, it's never been easier to become a developer. Just click the build number 7 times, yeah. Okay, so once you've given it authorization to deploy debugged applications, this should come up, choose a running device. I'm going to click OK here, and just a moment. So if you do this the first time, it takes quite a while. You see here waiting for debugger. Don't be alarmed. This may take a few minutes to actually do something. It will look like it's stuck. So this is only the first time you play the project. I don't know what's going on behind the scenes, but it's definitely doing something. You can see down there it says attaching to the app. So we're just going to give it a moment. There we go. So here's the same app that we just saw on the desktop is now running on this tablet. For starters, you'll notice some things which are not so nice. Is number one, this doesn't look like Android much. Actually looks like some older version of OS X. Also, it's like the GUI is a bit laggy. It's not very responsive. And we'll see exactly in this tutorial how to fix that and some tips and tricks to get a very good response of your UI.
I'm not getting this app native.
You're not getting this app native.
You need the NDK.
Do you have the NDK? Yes. So if you go to Preferences, there should be in SDK tools, I believe, Android NDK that needs to be installed.
Yeah, installed.
It's installed.
Yeah.
Let's see. So what is it?
Also this,
Is this is this a developer phone? Because the problem is if it has a developer flash. Oh, okay. Okay. Anybody else? Did this work for some other people? Okay. So you can probably follow this on video. I'm assuming that not everybody has a device here.
So if you don't see this drop down here, then it indicates that the build is failing, and that's probably because you don't have Gradle installed. So if you connect and download Gradle, which should be done automatically, then you should see these build configurations.
Yeah, it'll be done by the build, but we have to, so Gradle gets installed the first time you try and build something with it. Before that, it's just sitting there as a little stub. So you should be connected the first time you build, and you should be ready to spend 3 or 4 minutes watching things download. That's a one-time deal, though.
Yeah, that's what I was. I mean, this is a fresh device. The Mac.
Is anyone able to see that drop down? No one else is? Just one person.
And what are the problems? Okay. Yeah, so if you haven't downloaded the NDK, I'm afraid.
So in the prerequisites, there was like this audio echo sample which would have downloaded the NDK.
Yes. So this is what I said earlier. The prerequisites ask you to open that project, because then actually Android Studio will be smart enough to download all of this stuff. So this is a virgin machine. I just sort of did this yesterday. I opened the Android Echo project to be on the same page, and it's Android Studio 1.4. So this is what it should work with. Okay, I'm going to jump a bit ahead because we have a lot to go through. So if you would want to skip ahead, we just finished this here. We're now here at 02 add Android Studio project. That's what we just did. Now we're going to go back to the Pro Juicer, and we're going to change some of these build settings here, some of these Android Studio settings. So first of all, it's probably nice to have an icon or something, because right now you just get the standard Android icon. So here I have icon small. If you select the drop-down menu, you will see power.png. What we'll also do is we will give it a nicer theme. I mean, if you saw on this device, it had the little theme bar at the top where the application name is. And typically for Pro Audio devices, you would like it to be completely full screen. So to change this, here's Android theme. And you see that the introducer already suggests this theme no title bar. So we're just going to add that. Android style theme no title bar. Okay. And what this app requires are some permissions. I will talk about this a bit later in 23 when we're going to upgrade the SDK version. We're going to leave it at 10 for now. We're going to ask for recording permissions, because this is what the synth requires. And we don't really need internet permissions, so we're going to disable those. Yep. So once we have that done, all we have to do is just hit Command S or save. And if you now go back to Android Studio will pick up that some of the Android manifest files have changed, and you can just click Sync Now, and then we'll pick up the changes. So now. This is syncing basically Android Studio with what you just changed in the introducer. And I'm not going to run it right now because it would. So you can see this. The pop-up menu is gone. It's because right now it's syncing down here. You see 2 processes running. So don't be alarmed if you can't run it right now. You can see that it's now So it has to resync, has to reanalyze, because I think like the compile flags might have changed, so it has to recompile the project. See, now that that's finished, I can now click on App Native and run again, which I won't do because nothing much has changed. You'll just see the title bar go away. So what I just did, I just did that. So if you want to skip ahead, that's 3 icon theme permissions. But if you do skip ahead, make sure to resave the project, because obviously in the Git repo, I don't have the actual project folder, the Android Studio project folder in there. So you have to resave and then sync. So now let's actually add the meat of the code. Let's add the synthesizer. So to do that, I'm going to go back to the producer. I'm going to click on the Files tab, and I'm going to add some binary data. So I'm just going to do right-click on binary data, add existing files, and add singing.ogg. And the source, we're going to add the actual processor. It's a JUCE audio plugin, audio processor, here called Android Synth Processor. So now that that's in, let me see, do we need anything else? Nope. So I'm going to do, again, save project. Just head back to Android Studio. Android Studio will tell me to sync again. Now syncing takes always a bit of a while, but it's only really when you need to resave the introducer project, which you shouldn't be doing too often, but once it's synced, we can see that we now have Android Synth Processor here. And we should also have the binary data. It's now in here. So the Gradle build is still running. I'm just going to let it end for a moment. I'm just going to let the Gradle build run, because I want to show you that the Android Studio code completion is works very well. There are not many IDEs that get code completion right with JUCE, due to the way we include the JUCE modules, but Android Studio gets it right. So let me just wait. Okay. So to hook up the synth, I'm just going to add a few lines of code. I'm just going to include the header. So I'm just going to there. It suggests me Android Studio synth processor, and I have this player, which is just an audio processor player. It's the standard JUCE class. Sorry, I was in the main component file. That was not the right file. Let me take that out there. I wanted to do this in main. So let me just delete that there again. Wouldn't have harmed. Main. Let's go up. Here's the include paths. Paste it in. There we have the device manager. And all I want to do is just do player set processor. And I'm going to call this synth. I have to add that variable. See, it's telling me there's an error. It doesn't know synth. So this is the auto-completion picks this up very nicely. So I'm going to scroll down at the very, very bottom, and I'm just going to add this Android synth processor synth. So that should be it. So again, we just here in the initialize routine, we just do player.setProcessor &synth, and we just add that as a member variable. Okay, so let's run this. And if we could now have sound for the tablet, that would be fantastic. So this, here we go. So you see that it now starts up a lot faster. And do we have sound for this? Let's see, maybe, nope. Okay. I know it's hooked up. Let me see if there's sound coming out. Yeah, there we go. And the idea of this little synth app is that you don't like that voice, fine. You press record and you go. So that's the, and you have a nice little reverb slider here. Yeah. Okay, so that's the Android synth application. Now, how do we add MIDI support? Ah, yes, sorry.
Is Pro Juicer also able to pick up changes in the Android Studio project?
No, it doesn't.
Okay.
But it's the same with other exporters. So if you have an Xcode and you add a file to that, Introducer won't pick that up either.
All right.
So this is, yeah. Okay, so now we're going to add MIDI support. And there's really nothing special because, I mean, JUCE is cross-platform. You already see Device Manager add MIDI input callback. This is just relayed to the processor. The only thing I'm going to do is, because, I mean, normally in a desktop app, you would have a little settings window where you would say, I want to have MIDI from these devices. The only thing I'm going to do on this Android tablet is take a bit of a different approach. I'm going to start a timer, which just automatically opens any MIDI device it finds. So every second, it will just see, are there any new devices available, and just enable the input from them. So I'm going to derive from timer here. Here I'm going to start the timer at the end. I'll show you how to jump ahead in a moment. It's not much code though. So I'm just going to start the timer here. And here in my private section, let's add a timer callback. Void timer callback. Override. Oops. And here we are going to do just check what devices are available. So devices, there's MIDI input. So you can really see the code completion in action here. Get devices. And I'm just going to enable any device that it finds. Here we go. Device Manager, set MIDI input enabled, devices, and true. So let's see, yep. Android Studio thinks that's correct. I'll trust Android Studio. So if you want to jump ahead here, after adding the MIDI support, we would be here. So let's go back to Android Studio. Let's run this. So this is the same you would do. This is not Android specific at all. This is the same you would do on a desk. I mean, you could do this on any platform, of course. But sometimes, I mean, the user experience on a desktop might be, if you're creating an audio application, is that you don't want to open all the MIDI inputs by default. But this is probably the best thing to do on a mobile device. So let's just turn on the screen. Again, waiting for debugger. And I have let's just wait for a moment. So here we go. And let's connect the rise. Just a moment. So, oh. Okay, that did not work. Interesting. Don't know why. Let's see, it's not, for some reason, Android is not picking up the device. So maybe my connector is somehow broken. So somehow Android is not telling me that there's a USB MIDI device attached. So I don't know why that's happening. Okay. Sorry, there must be something wrong with this cable. I'll figure out that later. So normally, if you attach a MIDI device, Android Studio will have a little thing here, a MIDI device attached, which don't know why this is not working. Okay.
Try this.
Okay. Do you have the? Let's see. Do you have the Android synth running on this? No.
No, I don't. You have to redeploy it.
Yeah. Let's see, that's strange. Or did I have any mistake here? Timer callback, start timer. Let's just skip ahead. I don't think.
Did it work on your tablet?
I don't know yet.
We would have to redeploy. Let's just skip ahead. I'll figure this out later.
USB-A cable. See if that works.
Yeah. No, I don't know why. Is this not in MIDI mode, right?
It's in Bluetooth mode.
It's in Bluetooth mode.
It doesn't matter when you plug it in. It should go
Oh,
on.
okay.
Yeah, sounds okay.
Strange.
Sorry.
Okay, maybe I did something wrong with my code. That's strange. What I could do is I'm just going to check out. Maybe I just did a mistake. Add MIDI support. So I'm just going to check out this. I know works. Say stash. Stash failed. Discard this. Yes, of course, I know what I did wrong, yes. No, I forgot to update the SDK version. Obviously, Android MIDI is only supported in SDK 23, so I didn't update the SDK version. Yes, that was a problem. So, sorry about that. So, okay, so open the producer again. The missing step was here, that we want to upgrade the minimum SDK version. If you don't have one of the new Nexus devices running Marshmallow, then you should leave that as is. Keep it as 10, but for MIDI, we want to put this on 23. So let's save the project again. Okay, let's see, Android Studio. We'll want to sync. There we go. So a version, some notes about this version number. So there is currently a bug in JUCE. Unfortunately, I only noticed this last week, is that Marshmallow has this new permission system that at runtime it asks for permissions. And we want the Bluetooth permission to be able to access a Bluetooth MIDI. And if you're deploying for SDK 10, for example, and you ask for permissions, then when you install the app, it will tell you which permissions are required, because you're targeting older devices, and that's how that used to work. And then you would get these permissions. But with version 23, at runtime, you have to ask the user to be allowed to access the Bluetooth. The thing is, it works fine if you're a developer, because what we just did is we already installed the SDK, the app for SDK version 10. It already asked for the permissions. It already received the permissions from the operating system. The operating system already said yes, because it came from ADB, and it was targeted for SDK 10. And so if you upgrade this to 23, everything will work now. But the problem will be that, if you would now deploy this on the App Store as targeting version 23, and a user would download it, then it wouldn't work, because it wouldn't have the permissions to access the Bluetooth. But I already have a fix for this. It just has to be code reviewed, so will come out very, very soon. So this is telling me that it doesn't like the Gradle build. Let's see. Just give it another try. Gradle build running, you see down here. A little spinner. Oh. Timer callback cannot be overloaded.
Does it take a parameter on a callback? Did you derive the class from timer?
I did, yes, I did. Private timer. Okay, this wasn't intended as a duplicate declaration. Here we go, yes. Yeah, that's not good. So what happened there was that on the branch I checked out, I had a bit more elaborate version of checking if I actually only enabled the inputs of new devices it found, where it doesn't really matter. I mean, you can just always re-enable devices that it already found. So that was that. So the missing step I did was not to update the SDK version number. Okay. So let me talk about, while this is running, about the Pro Audio detection on Android and how JUCE deals with this. So we, obviously with JUCE, we want the best experience for the customer. So what we don't want, so we want the lowest latency, but at the same time, we don't want any audio dropouts. So if you're running on an older device where we set the buffer size, the default buffer size. You can always change the buffer size in JUCE, but we set the default buffer size to something quite conservative because there's the Nexus S out there which has 200 milliseconds latency and doesn't have a very good CPU. So we set the buffer size quite high. You can always set that lower if you want to. You can have a settings dialog where you set it lower. And what we do in JUCE though is that on pro audio devices, we know it has a good CPU, we know it has low latency audio, so we set it to the smallest buffer size available. So okay, so this has now deployed. Let me put in the rise. Oh, there we go. Oh no. Oh, wait. So, there we go. Okay, sorry about that. Okay, now I'm going to do all the code changes of the last few branches all in one go because they're very, very small. Again, you can then jump ahead. So I'm going to do add Bluetooth button, low latency detection, and enhanced performance. That's the magic bullet there. All in one go. These are just all code changes. So to add the Bluetooth button, this is a feature. How do you pair MIDI Bluetooth devices? Now, the big problem is if you want to do this in a cross-platform way, it's actually quite hard because iOS wants to use a native dialog provided by the system. And there's no way around that. It's a permissions, a security thing. So on iOS, you have to ask the operating system to open a native dialog for you to pair MIDI Bluetooth LE devices. On Android, you can do this all programmatically. So how we deal with this in JUCE is that for Android, we've implemented a dialog for you. And I'm just going to add the Bluetooth button to this code. So way down here, there's a button, record button. I'm just going to add Bluetooth button. There we go. And given a name, Bluetooth. So, oops, maybe I should spell my Bluetooth. So add a comma there. Okay. So here we have the same as with the record button. I'm going to do record, add Bluetooth button, add listener, this. Add and make visible, and Bluetooth button, it's perfect. But now we're going to check if this device actually supports Bluetooth LE MIDI, because it's not worth having a button there. I'm going to disable it if it doesn't have Bluetooth MIDI. So I'm going to do Bluetooth button set enabled, and then there's something called Bluetooth MIDI device pairing dialog. That's a JUCE class, and it has two methods. It just has is available and open. So I'm going to do is available, use code completion. There we go. So this Bluetooth button will only be enabled if Bluetooth is actually available. Now we're going to have to hook up this button somehow. So in the resized method, I'm going to copy this line of code, which just adds the right bounds for the button. Oops, Bluetooth button. And when the button is clicked, I'm just going to do else if button equals Bluetooth button. And then again, this MIDI, Bluetooth MIDI pairing dialog, open. And this also has a return value, a Boolean, if opening this dialog was successful or not, because this could fail for some reason on iOS. Okay, so that was adding the Bluetooth button. Now how do you detect in a cross-platform way if you're running on a device that has low latency? So again, as I said, like if you're on a pro audio device on Android, we would set the lowest possible latency. So I've written this little function to detect, hey, is this a pro audio device? And say the juicy way of doing this, or the cross-platform way of doing this, is just checking, well, what default buffer size has JUCE chosen for me? And this is a good indication if this is a low latency audio device. So I have this little function here. All it does is just says, get all the available buffer sizes, and is the current buffer size the lowest buffer size? That's all it does. So I'm going to add this to my component. I'm going to pass this to the main window. Here, the main window is down here. Bool low latency. Add this as a parameter. And then the component needs to know about this. So main component. So we go up here. Bool low latency. So, and then here I have this little app icon you saw on my GUI. It was on the left. There was this weird app icon. I'm just going to highlight this app icon if we are on a pro audio device. So I have low latency, and there I have the text button color, which I will misuse to sort of get a highlighted color by doing button on color. So this is now detecting if it's running on a low latency device. And now, as promised, the last few changes to get better performance, and these are really, really crucial for Android, is to enable GL rendering for the whole GUI. We've completely rewritten the GL backend in JUCE for Android, and it's a lot stabler. It has a lot better performance. So it's really worth, if you're on Android, it's really worth always enabling this.
Isn't it like a 10 times increase in performance?
Yeah, definitely, yeah. So without this, it would do software rendering, which is obviously quite slow, and with this, it will just use GL calls to do all the rendering. And another thing, this is a nice little workaround inspired by Dawn. If we disable the screensaver in JUCE, we do a nice little trick that we will inject little touch events onto your app. And Android, what it does, if it registers that you're a touch, it will give you best system performance. I think it's Project Butter or something. And so we simulate that you're always touching it. That will drain your battery quite fast. But if you want to have the best performance, like if you know, let's say the tablet is plugged in, then it's worth disabling the screensaver, because that's how we disable the screensaver with Java calls, but we also do these on Android. We also do these fake touch events. Just to give you the best performance.
Just to add, we know this is like a massive hack. We are working on like a better API to make sure you can have consistent performance without going like this.
Yeah. And where do we have comp? Here we have the main window. There we go. GL context, we need a GL context here. So we do OpenGL context. So this is how you enable OpenGL rendering. Just call this GL context. It's very simple in JUCE. So this will give us an OpenGL context where we can render into, but you can also tell JUCE to simply do all the rendering of a component to that context. So I'm going to do attach to comp, which is my main content component. And similarly, if in the destructor I would want to detach. That's it. Okay, so those are the two performance enhancements that I want to add. And the last thing I'm going to do is I'm going to add a more native look and feel to the app. And I just want to highlight that this is really, really simple in JUCE. There's these look and feel classes that if you override them, you can completely customize the look and feel of your app. It's basically like theming on steroids. So if I go to files, I'm going to add another existing file called material look and feel. And this is, let's say, a material design inspired look and feel. So I'm going to save the project. Here you see Android Studio picking this up. It also wants to sync. And if I look at this file, just to give you a brief idea, my font is quite big, but it's not much. I mean, it's about 1.5 pages if you have a decent font size. So it's very, very simple to customize your look and feel, to make it look a bit more native, especially with material design, because material design is basically flat colors. So that's always nice. how do we add a new look and feel? So I've only added a file. I'm only going to add 2 lines of code to my app to completely change the theming. So down here, I just need a member variable called material. Okay, I think the syncing is still running. Oh, there it is. Yeah, material, look and feel. Material. There we go. Look and feel. Look and feel. Okay. And now here in the initialize, this is the second line required. Just anywhere you want, really, you can do look and feel, and then set default look and feel. So that's all you need. There you go. Okay, so I did a lot of code changes, and I'm seeing that it has 2 errors. Let's see what Android says. These are, I need to look here. Yeah. There we go. What does it not like? It does not like main window. Let's see what the error message is. Okay, we'll see. Low latency. Let's just see what if we build this, what happens. Also notice that obviously for the GUI to be fast, we're running this in debug mode. So I mean, obviously, like if we couldn't do any like massively complex audio if you're running in debug mode, because the optimizations will be off. So if I run this now, please don't expect like super fast response. I can run it in release mode, and then it will be really good. So it's waiting for the debugger. Okay, so here we have this nice material design look and feel. Again, this works. We have a nice little slider. You can see that this is highlighted. It shows up as a pro audio device. One thing I forgot to do right now is to actually enable Bluetooth, so that's why the Bluetooth button was disabled. I'm going to do enable Bluetooth here. I have to check that the Rise is in Bluetooth mode. Nope, it isn't. Okay, let's turn it on again. Now I'll just restart. Okay, the Rise is coming up in red mode. I've never seen that before. It's red.
Oh, low battery, I think.
No, I charged it. I charged it yesterday, but try it.
Do our best and do stuff anyway.
Yeah, if you plug that
You can
in.
roll it.
Yeah. Oh. No. Doesn't like it. Let's see. Anyway, so I have Bluetooth enabled. The Bluetooth button is there. Let's see if it might just yeah, it does pick up some Rise. Maybe it's the Rise on the other room. I don't know. So I click on connected. Again, on iOS, you would see the native dialog. Here, it's this is our JUCE dialog. You could also customize this with theming if you would want to. Okay. No.
Yeah, it's the battery's dead.
Yeah. Okay. I think I picked up the Rise there. So if you'd be playing there, because this one has a different name. Okay. Let's try this again. Not coming yet.
It's in Bluetooth.
See, maybe this is it. See.
No, you're getting the other one.
No, getting the other one. Okay. Let's see. Sometimes, is there a hard reset for it? Let's just wait. No, it's not picking it up. I know this one's just called Rise 25.
Yeah.
Okay.
It's in Bluetooth right now.
Yeah. Okay, so that was the tutorial. Also, it might be an issue that we have many Bluetooth devices around. So if I try this in my office when we all have our Rise and we're all testing Bluetooth, there's no chance of getting it working. Yeah, no, it's not.
So just quickly, does anyone have a working app on phone? No?
It's on red again.
Not one?
Yeah, no, it's going on.
Okay.
Like it needs to be powered.
So please see me. I've tested this on a lot of devices, so it should really work. Yeah, but just, I had a hiccup by not changing the Android SDK number that caused some of those errors before. But yeah, if you weren't be able to reproduce this, then just see me and I'll see where the problem is. Okay. Sorry? Right. Somehow, yeah, maybe, if the app native didn't come up, then you need to probably do this on a decent internet connection because it's downloading Gradle in the background, I think. Okay, so thank you.